The first slide is the title of the talk, so you know if you are in the right place or if you are in the wrong meeting by mistake. But the title is a bit strange. How can MySQL boost your applications? Oh, now it's better because MySQL can actually boost or kill your application. And I will try to explain why it can kill them and how to get the best performance from it. Well, of course, it is a general talk, so don't expect to become experts in the field, but I can tell you something about query optimizations, about transactions, and other general SQL topics. So this is the general slide to show who I am and why hopefully you may want to hear me, but let's proceed. So before beginning, I would like to tell you, okay, this talk applies to MySQL specifically. It also applies to Percona Server and MariaDB mostly. They are forks of MySQL for those who don't know. But actually all relational databases are based more or less on the same principles. So even if you use something completely different, this talk should be useful anyway. So this talk is not about the following things. It is not about PHP code or some ORM, because it is about SQL. How you build that SQL, well, it is actually up to you. The code to generate the SQL is up to you. I wrote that it is not about query optimization because actually query optimization is a very wide topic and books have been written about it, and I will just show some slides about this. Okay, so let's proceed. Okay, so actually there is a valid question that I was asked when I made a similar talk before in another group, and the question was why I am talking about MySQL at a PHP event, which is a very good question, and I have an answer actually, because first of all, if you think about it, MySQL and PHP came out more or less in the same period, or at least they became famous and widely used in the same period. And the period was actually when the web became widely used. Why? Well, because if you think about it, the early days of the web, basically the internet were, how can I say, it had certain ideals like, you know, information sharing. So basically they are the same ideas that are also at the base of open source, right? And of course, both PHP and MySQL are open source. And it's not only that, actually. The web in its early days was also very simple. I mean, it was basically, it basically consisted of very simple sites with very simple logic. Many sites were static, others had some programming with PHP or with Perl, but the logic again was really, really simple. And PHP at the beginning was also very simple, and MySQL at the beginning also was very simple. It was easy to learn, which is still, actually, it's still easy to learn, probably a bit less because now it's more feature-rich. And that's the other point. Both PHP and MySQL evolved a lot along with the web, and they became more enterprise technologies, or at least they are used also by enterprises. So actually they had a very similar evolution, and that's probably why most PHP programmers, especially in the early days, used MySQL. And actually, even today, I think that most PHP programmers use MySQL. So let's proceed with the talk itself. And before getting into the SQL, let me show you some practices, some good practices that I advise to follow about your development machine. I mean, your local machine, your laptop, or the virtual machine that you use to develop your applications. So, first of all, I suggest to put 3 small changes in MySQL configuration files. And the changes are, first of all, enable the slow query log. Second, long query time is a parameter which defines when a query is considered slow. In this case, we are saying if a query takes more than 0 seconds, it's to be considered slow. So all queries are logged into the slow query log. And then we also enable performance schema, which is basically a system database which contains tables about the performance of your databases and how they are used. So basically what I suggest to do to take advantage of these things is before beginning to test something, you can empty the slow log. And then you can do your tests in any way. I mean, it doesn't matter if they are automated unit tests or if you just use your application manually to make it do something. In any case, it will start to run queries, and those queries will be written into the slow log. I also suggest to run this simple query. Basically, truncate table means completely empty a table. And the table that we are emptying is a system table which contains the summary about some queries executions. And the reason is that we want to be able to reset all information about previous tests that we made and collect information about the queries that we are going to run now. And after we tested a bit the code, we can actually run some queries on that table. First of all, don't worry, because I will make the slides public, so you don't need to take a screenshot or write down the queries very quickly. I just want to explain the concept, and the idea is the table contains information about how queries run, how they are executed, and with this first query, we only select the queries that returned some errors. Why? Because as a database consultant, almost every time I put my hands on some production server, I see that there are queries that generate errors, so they fail with an error, and most of the times no one noticed because these errors are not monitored in any way. And yeah, it is a good thing to see if errors happen and why. Sometimes it can happen that a query always returns an error. It is simply wrong because maybe it mentions, for example, a table that doesn't exist anymore because applications evolve over time, and sometimes, well, the schema also evolves, and sometimes maybe some feature is dropped, or maybe it changes. Some old queries remain, and they still put some workload on the database server, so it is a good idea to simply drop them. Okay, this is another query to see basically which queries never return any rows. Well, not never, but which queries didn't return any row or didn't modify any row, okay? As you can see, there is an order by clause. Basically, we order them by the number of rows they examined. Why? Because even if they don't return any row, they still do something. MySQL needs to read the base tables and find out that no row should be returned. Those queries sometimes are useful for the same reasons I mentioned before, and sometimes you just would like to drop them. But even if it's not the case, well, probably if the query don't return any row, this could mean that there is some kind of problem that you want to investigate. And the final query that I suggest to run is about query performance, because what we are asking to see is the queries that don't use any index, or they materialize a lot of data in memory. So this is something that happens, for example, when you have a query which requires some sort of two-steps sorting, and MySQL have to write data into memory. If you're lucky, if you're not lucky, it will have to temporarily write data on disk, and this means that the performance will be poor. Oh, I see only now a message that says some slides ago an echo is missing. Sorry for that. And thanks, Ramsey, for letting me know. I will fix the slide before making it public. Anyway, let's proceed and let's talk about the most important component of databases to make your queries fast, which is indexes. So how do indexes work? Well, I can explain very briefly. Just keep in mind that they are ordered data structures. And you can think about indexes like a phone book. Unless you are very young, you probably use the phone book in your life, and you have in your mind how it works. Basically, you know the alphabet, and therefore, if you're looking for a specific person, you open the phone book in the middle. You look at maybe the last or the first person in that page, and then you decide if you have to try again in the left portion of the pages or in the right portion. And it's actually how database indexes work from a conceptual point of view. So a phone book is, well, could be represented in a database as a table with an index on the columns last name and first name, okay? A hint, first last name and then first name. Why? Because the order matters, okay? Why a phone book is useful? Because you know that the last names are orders, and only when you see a series of persons with the same last names, they are ordered also by first name, right? So basically, how do the next slides work? Well, basically, I will show you some queries, and we will decide together. Well, actually, I will tell you, but you are able to interact with the chat, and we will reason to see if those queries on the phone book table can actually use an index. Okay, so this is actually a table, but if you don't understand the syntax, it doesn't really matter. Again, what really matters is that the table has first name, last name, which are indexed columns, the address and the phone number, which are more columns, but they are not indexed. And again, the index is on last name and then first name, okay? So let's see some queries. Okay, select, imagine that there are some select certain columns from phone book, and then they are followed by these where clauses. I hope that everyone understands some little bit of SQL, but actually this is very simple syntax. So again, if you don't understand, please let me know, but I think I can assume that most people understand it. Okay, so while I was talking, I assume you had the time to take a look at these where clauses and probably think which of them can use indexes and which not. I will tell you. The first one, yes, can use an index. And again, think about the phone book. Can you use the phone book to find all the persons who are called Becker? Of course you can, because they are ordered by last name. But the second where clause cannot use an index. Why? Because can you use a phone book to find the Toms, all the persons called Tom? Well, in theory, yes, you can, but to do it, you should scroll the whole phone book and read every single person in it. Because it's not ordered by first name, it's ordered by last name and then first name, okay? The following queries, well, actually, they are very similar, right? One is where first name equal Tom and last name equal Becker. Can I use it? Can this query use an index? Well, yes, of course, because you can use a phone book to find someone who's called Becker and his first name is Tom. The last one is just the same thing written in a different order, and I inserted this option because it is a question that I was asked frequently when I explain these kind of things to developers. And the answer is yes, of course, it can use an index because it doesn't matter in which order you write the conditions. MySQL will be, of course, smart enough to understand what to do. Oh, okay, I'm glad that John says he's learning important things. So based on what we discussed, we can already infer a first rule, which is a query can use a whole index or a leftmost part of the index. So in our example, it can find a person based on last name and first name, or it can find a person based, well, or find any number of persons based on their last name. Okay, so index, whole index, or leftmost part of an index. I see there was a question that I missed. Let me check. Sorry, I'm not familiar with the interface. Okay, so Victoria asks, do I mean that an index of last name, first name, I can optimize query number for? Yes. Okay, I hope you can see the slides even if I cover them temporarily. Yes, definitely. Again, queries 3 and 4 are basically the same thing. It doesn't matter in which order you write the conditions. Okay, so let's proceed. Okay, now let's see some more examples. And as you can see, well, the first one is something that we already saw. It can use an index, but basically here you can see all the almost all the existing SQL operators. Okay, so in case you are not familiar with the syntax, the options 2 and 3 are the same thing. Basically, it is a not equal operator. You can write it in two different ways, but it means exactly the same thing. And then we have where last name greater than Becker, greater or equal, and so on. So which of these queries can take advantage of an index? If someone has an answer and can write it quickly in the chat, we will check. If not, I will answer for you. And basically, okay, as we already discussed, the first can use an index. The second cannot use an index. Why? Because again, think about the phone books. Can you use a phone book to find all the persons who are not called Becker? Yes, in theory you can, but again, what you will do is to scroll the whole phone book. Yeah, okay, maybe there is a small optimization you can have, because when you find the first Becker, okay, you know you have to skip some rows, but actually it doesn't really matter when it comes to query execution. The thing is trying to implement any type of optimization for not equal in MySQL or in any other database would be basically a waste of time. It would just complicate things, but the performance will remain substantially the same. So the takeaway is not equal is an operator that cannot use any index. What about the next operators? Well, the answer hopefully is intuitive, because we said that indexes are ordered data structures. So all these operators from option 4 to 7, they are all something based on order. Okay, so greater than Becker means any string that in an alphabetical order comes after Becker. Okay, lesser than Becker is the opposite, any string that comes before Becker in alphabetical order. So basically, we can say that all operators can take advantages of indexes except for not equal. Now, there is something that you could be familiar with or not, because in the examples 3, 4, and 5, there is a like operator. For those who don't know, like basically matches a string or a text against a pattern. So basically, what we have here is patterns that have a special character, which is percentage symbol. Percentage in this context means any character, any sequence of character, or no character at all, actually. So the third query means where last name starts with a B or is B. Okay, the next one is where last name contains a cape E, and the last example means where the last name ends with R. Okay, so we have an answer. Great. Victoria says 1, 2, and 3 can use an index. 4 and 5 cannot. Exactly. That's absolutely true. And I would like to explain why. Because I believe that it is intuitive why the first 2 queries can use an index. Because basically, they check an interval. Okay, they check all the last names that are between B and C, okay? It is written in two different ways, but they are the same thing. If you look at the third query, is actually the same. So checking for the beginning of a query, checking if a last name starts with B is like checking if it is between B and C, okay? So again, it is an operation based on the order of the last names. And even if you don't remember these, again, think about the phone book. You can easily use it to find all the last names starting with B, but you cannot use it to find, for example, the last names ending with R, okay? So let's continue. And Ruth asks if queries 1 and 2 are executed in the same way, and yes, they are, absolutely. Again, it's just different syntax. You can use the syntax you prefer. It's a matter of taste. Okay, so the second rule we can infer is you can use an index to find a value or a range, okay? So a single last name, for example, or a range of last names, okay? Let's proceed. Okay, this is maybe slightly more tricky. So we have basically two examples where we have or, okay? But they are different because in the first case we have, well, last name equals Nimoy and, sorry, well, last name equals Nimoy or first name equal Leonard. And the next is, well, last name equal Nimoy or last name equal Shatner, okay? Can anyone guess if they can use indexes or not? The second one, Victoria is too good because actually, yes, she's absolutely right. The second one can use an index because, again, instead of looking for one last name, we are looking for two last names, but MySQL will simply run the same type of search twice, okay? But it can be used using indexes, of course. The first one cannot use an index because even if we could use an index to find all the Nimoys, it wouldn't help because then we would need to find all the Leonards, okay? No, thank you, Victoria. It's great that you actually can guess the correct answers to the questions. Okay, okay, so the next query that, the last rule that we can infer is or on different columns is not fully optimized, okay? Well, okay, it is in the second example, but because it is an or on the same column, okay? In the first case, it is not optimized at all, okay? So let's proceed. And okay, this is the last set of queries, don't worry, but it's also, it could be the most tricky probably. Because, sorry, there is a question. To optimize one, in this slide, I guess, you would need another index on first name? No, actually, well, the answer is not really straightforward because it depends. It depends on data distribution. If MySQL thinks that there are not many rows to find for each conditions, so there are not many Nimoys and not many Leonards, in that case, Ruth, you are true, we could have two separate indexes, one on last name and one on first name, and MySQL will use both. But to be honest, often, even if MySQL chooses to use both indexes, it is not a great optimization. Why? Because MySQL will have to use an index, put the results in memory, read another index, add the results to memory. So basically it will still have a lot of work to do. And also in most cases, actually, it will simply read the table completely instead of using any index. Okay, so again, this is the last set of queries. So as you can see, the thing here is that we have one condition on last name and one condition on first name. But the characteristic of these queries is one condition uses equal and one condition uses greater than. It could actually be less than. It would be exactly the same thing. Okay. So no one provided an answer yet, so I will tell you. The first query, yes, of course, it uses an index because it's just a matter of finding last name Nimoy and then the row where first name is Leonard. But the next one cannot use an index because, well, not completely true, because it could use an index to find all the persons whose last name is Nimoy, but then, okay, no, sorry. I got confused because, sorry, they have 4 options and they are quite similar. So I got confused myself. The second one, yes, also uses an index because what it does is it finds the first row for Nimoy, and then starting from that row, it will scroll the index until it finds Leonard, and from that point, it will return every row it finds, okay? So this query can definitely take advantage of the fact that an index is ordered data structure. But the following 2 queries cannot use an index. Why? Because the first part is last name greater than Nimoy. And that part could actually use an index, but the index will not really help to run the second part quickly, okay? So, for example, we find all the last names greater than Nimoy, but for each last name, there could be 1 or more Leonards, okay? The order doesn't really help here. So yes, MySQL will use an index for the first part, but this will not help a lot, okay? Most of the times when I explain this, I get a lot of questions because it is not immediately understandable, right? So I wrote a small examples here. I shown that basically take as an example the last query, okay? Okay, yeah, take as an example the last query. You can see that even if MySQL scrolls the index, yes, it will find all the last names greater than Nimoy, but it could find a lot of names that are not greater than Leonard, right? So actually the question by Ruth is absolutely correct. So in queries 3 and 4, the index would only allow MySQL to reduce the number of rows to be scanned to just the last names greater than Nimoy. Okay, So it is an optimization, but it is not a great optimization because it will still have to read a lot of data just to find the Leonards. Okay, so let's proceed. And the rule to infer is probably simpler to remember compared to thinking about the order, because the rule is the index usage stop with the first range. Okay, so we have equal, which can use an index. In the first example, for example, we have equal, which can use an index. Then we have another equal, okay, it can use an index. The query too. We have equal followed by greater than, which is a range operator. So yes, it can use an index, but whatever condition is after the first range operator cannot use an index. So in the third example, for example, yes, we said that equal should be able to use an index, but in this case, we have a range. After the range, whichever condition we have, well, it will not be able to take advantage of an index. Okay, so let's proceed. And okay, again, this was the last set of queries. Don't worry, the whole talk is not only about queries. The next topic is about using SQL properly to avoid executing a lot of queries. Okay. So, for example, we have the so-called N+1 problem. It is something that it is done by some bad ORMs. It is not just a theoretical examples. I actually saw some ORMs doing this. Fortunately, they were not PHP ORMs. They were probably JavaScript or, I mean, not JS or something else. But anyway, the idea is if we want to find all the books for a certain group of authors, what we could do in theory is we run the query on the author table, and then for each row we can find another select on the book table. But this is something that really you shouldn't do because it is extremely slow. The second example is what you should do instead. So if you don't know how to write join, I really suggest that you learn the syntax. It is simpler than it seems, actually. You just specify two tables, then you specify an on clause that says how the tables are related. This is a short talk and I cannot explain every details of joins here, but the basic idea should be clear. So another topic is dealing with duplicates, okay? Because I am going to explain how SQL allows you to deal with duplicates. And actually, you could obtain the same things by writing more PHP code. But when you can do something with SQL, it is better. The result will be faster. So basically, the basic syntax of insert, well, is what you see in the first example, and hopefully more or less you know it. You can also add an ignore keyword, which means even if the row we are inserting exists, don't generate an error. Just a warning. So the application will be aware that there is a duplicate here. What is the difference? The difference is that if we are doing this inside the transaction will not roll back, okay? I will explain a bit better transaction later, hopefully, because actually I can't see the time. So if I'm exceeding, I really hope that someone will write me in the chat. So the next example is basically a slightly more complicated syntax, but not really complicated. Basically, as you can see, we are inserting a row, but we also add on-duplicate key update. So it means if the row we are inserting is a duplicate, so it tries to duplicate a value in the primary key or in a unique index, then instead of adding a row, just take the existing row and change the following columns, okay? So in this case, we are specifying a new value for the column name, okay? Replace is an easier syntax to do almost the same thing, but it's not actually the same because replace doesn't update columns. What it does is it deletes existing rows if there are, and then it replaces them with the new rows. But basically, if the columns exist if the rows exist and we are deleting them, we are also deleting some columns that probably we don't really want to delete, okay? And also, for example, if we have triggers on the table or foreign keys on the table, this could have strange consequences. And also, there are some bugs in MySQL on how replace is implemented. And under certain circumstances, it can create data inconsistencies. Anyway, let's proceed. Here is a syntax to show how to insert many rows. Instead of running many inserts, you can run one insert with the list of the columns you are inserting, and then you specify all the values between the parentheses. And the reason is, if you do this, MySQL will receive only one query, will have to parse only one query, will have to elaborate only one query plan, and basically everything will be faster. So Ruth is asking, would that mean that replace could delete existing field values that weren't? No, not fields that weren't specified. I mean, for example, if we are inserting a row with ID 15, and we are using replace, okay, all existing values for the existing row with ID 15 will be deleted, but other rows are not affected. Sorry if I wasn't clear about this. Okay. Oh, and the last thing I wanted to mention here is, okay, sometimes in a relational database, you want to insert some rows in a table, and then you want to insert some rows in a linked table. Okay, so for example, here you have a user table, you are inserting some users, but then you also have an order table, and you in the order table, you have a column referencing the users, okay? So a column containing the users' IDs. When you do this, it would be useful to know the ID of the last row you inserted, in this case, in the table user. That ID is provided by the function last insert ID, as you can see in this example. And the reason is, if you do this, you will not have to run an additional an additional select. So running less queries is important because basically you add less work for the server. Here I wanted to show also another thing. You can actually sometimes you may want to delete data from multiple tables or update data into multiple tables. So for example, here, for example, you want to delete a user, but you also want to delete all the orders that have been placed by that users. So you can do it with just one query. I show how the syntax is very similar to join. There is just small difference, but it's definitely something learnable. Sorry, I didn't look at the chat for a while. Dan says, if you're doing a lot of inserts like as well, make sure. Yes, that is another topic. Yes, there is a MySQL setting that could be to could need to be adjusted if you are inserting many rows altogether or very big rows. But yeah, sorry, it's a bit separate topic now. Okay, no, Radan, you are absolutely right. It's just that the time is limited. So another syntax I wanted to show is returning. It is a syntax that exists only in MariaDB. I mean, no, it exists in MariaDB and a lot of other databases, but not in MySQL. And returning means, okay, Mr. Database, please insert this row and then return the values that you inserted, okay? Or delete these rows and then please return some columns from the rows you deleted. Why? Well, the first case is probably more obvious because if you think about what ORMs do, often they insert rows and they insert rows, but basically the primary key column, the ID, is automatic, so they don't know the ID for that row. So what they do is insert and then select. If you can do this with only one query, it's better. So you, again, you just add the returning clause to your insert or to your returning. There are actually also other reasons because, for example, you could have triggers in the database which modify the values that you are inserting, but this is a bit more exotic feature. So in most cases, you don't have to worry about it. Okay, sorry, reading the chat. Okay, good. Okay, I hope this is clear. If not, please ask questions. Oh, okay, Ruth asks, returning will also return the default calculated values? Yes, I don't have the time to explain what you mean actually, but if you have dynamic defaults calculated by the database, or if you have generated columns, yes, with returning, you will get those values. Sorry for the other side. I don't have the time to explain these in details. Okay, then I want to show that there are some other queries that you can merge to, for example, to create a table and populate it with rows. So, for example, here you have create table, This is a nice syntax. Create table past order like order. It means the table must have the same columns and indexes as order. But then we also need to add row, and therefore we use insert into past order select. So basically what it does is run this select and please insert all the rows you find into this new table, okay? Or you can use create table select, which is very similar, except you have a bit less control, okay? Because, well, the table that you are creating in this way could have some differences. The most remarkable is that it will not have indexes. Okay, sorry. Okay, sorry, let me see the chat. Okay, I didn't read the chat for a while, apparently. Okay, are the indexes able to improve performance in joins? Yes, absolutely. I'm sorry that I don't have the time to show examples, but yes, there is a very simple rule you can remember. When you have a join and you have, okay, select some columns from table A, join table B, and you have where, and you have, sorry, on A dot X equals B dot Y. Well, basically, the column that you are referring to in the second table should be indexed. But this is a bit more of a generalization because you should also keep in mind the order that tables are read when you run a join. Basically, the rule would be MySQL tries to read the smaller table, the bigger table first. And most of the times it managed to do this correctly. Sometimes it fails and reads another table first. So actually, it would be a bit too long as a topic to explain now. But the brief answer is yes. Okay, then I see more discussion about joins, but I cannot dig too much. Okay, great. Okay, then there would be another big topic, which is transactions, but basically I need to ask you if I have the time to talk about it, because I can't see the time and my phone is not in my pocket. It's 8:10. Okay, I can carry on. Great, thank you, Simon. So let's try to cover at least this topic. Okay, transactions. What are transactions? Well, this is a kind of academic explanation. We can skip it actually, and we can just show an example, okay? A transaction is what happens in two cases. When you run a transaction explicitly with start transaction, or when you don't do that, but basically you have the variable autocommit set to 1, which is the default. So if you never heard about autocommit, well, don't worry, it is 1 by default. So what autocommit does is, no, sorry, let's explain starting from the proper syntax. So if you use the explicit syntax, okay, you start a transaction, then you run some queries, not necessarily writes, they could be reads. In the first example, there is a select, okay? And then in the end, you run a commit or a rollback. Commit means, okay, make all the changes I've made effective, okay? What does it mean? It means that even if I run an update, an insert, and so on, the effects of these statements will not be visible for anyone else except me until I run commit. But actually, in some cases, probably some error of course, not on the database side, but probably something related to the logic of the application, some anomaly of course. So I can decide to roll back the transaction instead. So all the changes I've made will be undone. And if I use auto commit, basically, which is the default, basically each statement I run will be a separate transaction, okay? So I don't need to write start transaction, delete, commit, because it happens automatically, okay? Oh, if you have auto commit equal 0, well, I don't see many people doing that, honestly, but what it means is assume that every time I run some queries, I start a transaction, okay? So if I run a delete, okay, I started a transaction and then it remains open until I run commit or rollback. But it's a bit confusing probably, so that's why auto commit is the default. Okay, so here I have an example of another reason why transactions are so important. It's not just because you need to be able to roll back, but also because, as I mentioned quickly before, basically the data that I am modifying must be somehow protected from what other concurrent sections do. So let's take this example. I ran a query on quantity. I ran a query on product. I checked the quantity. Basically, I want to know if there is at least one product available in the stock. I also add lock in share mode, which means basically it puts a lock on this row. Then I run an insert to create an order, and then I run an update to decrease the quantity of the product in stock. Okay, and then I commit, and this is very logical. But suppose another concurrent transactions try to do the same thing at the same time, and suppose that the quantity is currently 1. Okay, so two concurrent transactions try to check the quantity, and okay, let's explain in this way. Let's pretend there is no transaction at all. Okay. Let's pretend we only have two concurrent sessions executing these queries. They both run a select and see that there is a product in stock, even if the quantity is only 1. Then they both place the order, and they both basically decrease the quantity of available products. The quantity will become -1, which is quite kind of weird, but even worse, both orders will be placed. So in some cases, it is not important to use transactions, but when we deal with important data like sales, money, and so on, but it is very important to use transactions and avoid ending up with inconsistent data. Okay. since we have a transaction, just to finish the explanation, since we have a transaction, what will happen in this case is that the second, two sessions are never exactly, do never happen exactly at the same time, okay? Maybe one happens 1 millisecond later, and the second one will not be able to lock the row, so basically it will wait until the first order is being placed, and then it will see that the availability of the quantity of the product in stock is 0, okay? So, or if you prefer, the second transaction is queued in this case, okay? But this is just a general explanation, but in practice, the isolation that that transactions put in place can be of different types, because there are 4 different isolation levels. The first is called read uncommitted. Below, you can see the syntax to use read uncommitted. Basically, you use set transaction isolation level read committed or read uncommitted just before starting a transaction. Okay, read uncommitted means that the transaction is highly inconsistent. This is against all I explained until now. I can see the changes made by other transactions, even if they are not committed yet, okay? So what is the purpose of using read uncommitted? Well, first of all, you are still able to roll back the transaction, but in most cases, probably you don't care too much. The thing is, it is useful when you need to run statistics on many values, and it is okay to read some dirty data, meaning some data that have been processed by other transactions, and I should be able to see now. Because when I run, for example, an average on 1 million values, I mean, small inaccuracies are perfectly okay. Okay, I see a question from Ruth. What effect does an uncommitted transaction have on memory and disk use performance? Yes, that is exactly the point. A transaction with read uncommitted is the fastest possible transaction. And when you need to examine a lot of rows, and again, you don't care too much about accuracy, you could use read uncommitted to make it much faster. But again, it is not really consistent. So the next level is read committed. It is a bit more consistent because basically, of course, you cannot see the changes that are being made by other transactions until they are committed. But for every SQL query you run, you acquire a new view on the data, okay? So basically, I run a select, and if I run it again, it is possible that I will get different results because in the meanwhile, someone modified something. What is the purpose? Well, basically, again, I will be able to roll back the transaction. So it still makes sense to use a transaction. But I don't have a consistent view on the data across the whole transaction. The next isolation level is the default one in MySQL. I specify this because in some other databases it is not the default. And basically, you acquire one view on the data when you start the transaction. So the result you will get with your queries across the whole transactions will be consistent. The last one is just a variation of repeatable read. So basically, every select I run becomes a locking select. I will not dig into the details because it is something that most of the times you don't need. But okay, sorry. So having said that, what are some use cases for read uncommitted? Well, as I mentioned, you could do it for again, to run some statistics and you don't care about small inaccuracies. You can use it to show the classical message like, hi username, your last access was, why can you do it? Well, because you are, hopefully you are sure that no one is modifying that data while you are running this query. Because other concurrent sessions shouldn't modify data about the current session. Or you can use it to delete old data. By old data, I mean data that have been archived somewhere else, or maybe not, but in any case, we want to get rid of it because we don't want to have very big tables. If you are deleting those data, well, you can assume that no one is using that data, right? Otherwise, you have more serious problems, honestly. Okay, so use cases for read committed. Well, you could do it to delete or update rows, for example, by ID from multiple tables, but related tables, and you are basically sure that no one else is modifying those tables during this operation. You can use certain types of historical data. So again, for example, you can show users payment history even if it requires running several selects, because you can probably assume that while you do this, the user is not making more payments. Okay, but this is just an example. Of course, depending on your application, you could have more cases or not. Yes, the next thing is that you can have read-only transactions. Read-only transactions only make sense if you use repeatable read. Okay, honestly, they have no purpose if you use read committed. Why? Because if you run two different selects, they will be able to see consistent data, and this is, in this case, the only purpose of using a transaction. By Ramsey, I hope that the webinar was useful for you. Okay, sorry. The thing with read-only transactions is that they are a bit faster than read-write transactions. Okay, by default, a transaction is read-write, but if you specify read-only, if you have many concurrent transactions, there will be for sure a performance difference. Okay. I wanted to conclude this topic by showing a couple of ways to kill MySQL. And not because I am encouraging you to do so, but because I think it is good to be aware that these things can happen. So the simplest method ever is you start a transaction, you read for example, all data from a big table, in this case order, and then you wait for, well, in this case, I said 1 day, no, sorry, half a day, but anyway, a long time. And basically, MySQL cannot keep transactions opened for an eternity because the changes accumulate, and every open transaction should be able to see some view on old data, so these old data cannot be deleted, and MySQL will try to keep track of every data changes until the very old transaction finishes, and in the end it will crash. Okay, so but it makes you think, right? Because doing this requires nothing except for the permission to select data from a table. But this is not a MySQL flow. It is something related to any database. So every user that connects to a database should be trusted. Otherwise, he's perfectly able to make some damage. And other method I wanted to show is, it is probably a bit harder to detect because what I do is I start a transaction and then I select only one single row, but I add the for update syntax, which I shown before, and basically it acquires a lock on the table. So the effect in the long term could be the same. Well, not just the same, it's actually even worse because not only I keep the transaction open, but I also prevent any other concurrent connection to modify or delete that row. Okay. So yeah, this was the last thing about transactions. I have another topic, but I suspect it takes too much time and we should actually conclude it here. But of course, if you have questions, please ask and I will answer you. If there are no questions, I will simply return control to Simon. Okay, I don't see any other questions. So it's been a great pleasure. Oh, there is a question. Can you leave slow log enabled on a production site? Does it slow down MySQL? Unless your workload is very, very heavy, the answer is not. It will not slow down MySQL. But even if it does, my opinion is yes, you should leave it enabled in production. Because even if you have a small slowdown, honestly, it's much more important to be able to investigate the performance problems you are having. If there is a slow query that is running often, you should be able to know it and then intervene. Okay. Ruth says, but be aware of log disk space, which is absolutely true. But that's up to your DBA because basically most of the times what you want to do is have the slow log enabled, then you should have some kind of consumer that reads the data from the slow log and send it to an external database. So statistics can be done on it. But this is a topic for DBA, so I will not dig into it. Okay, thanks, Victoria. Yes, Ruth, ensure you have log rotate, or but actually, yeah, the DBA should anyway implement some way to move the data from the slow log to some other data source, external data source. Okay. Okay, Chris, I would be able to talk about it in another webinar if I'm invited. Can I summarize the talk so far? Well, okay, yes, I tried to do it quickly. We talked about, well, I gave you some suggestions about your development machine. Basically, the suggestions are enable the slow log, enable performance schema, and then I shown some queries you can run to get the most problematic or strangest queries from performance schema. Again, the slides will be made public, so you will be able to see the queries. Then we talked about indexes, and the most important takeaways about indexes are probably you can use a whole index and you can use a leftmost part of an index. You can use indexes for several conditions joined by and, but not necessarily if they are joined by an or. Then we talked about several other syntaxes to, for example, insert many rows altogether with a single statement, or insert or delete a row and get some values from it, and some other examples to basically reduce the number of queries you run. And then we talked about transactions, because hopefully you should be able to use them to be sure that the most relevant, the most delicate data in your databases are always consistent. Okay, so okay, thanks a lot to everyone, and I hope to meet you again, hopefully in person next time.